This is assignment 56 in class I. There's two of them. This is the short one. I also have some bell work problems that I'd like to do with you first. Right. Let's talk about antiderivatives. If f double prime of x is 3/4 t, if f double prime of t is 3/4 t to the negative 1/4, what can we say about f to the fourth? This is second derivative. This is fourth derivative. Well, I think I'm going to have to start by saying, what's the third derivative? I'll bring down that 1/4. I'll subtract 1. And now I'll be able to answer the question, what's the fourth derivative? And I'll have 15 over 64t to the negative 9. Okay, but what about going backwards? What about if I ask for, what's f prime? Well, think about what we did to go from here to here. We brought this down and subtracted 1. Well, what if we want to go backwards? We push this up and we add 1. If I add 1 to this, I get positive 3/4. There it is. So t to the 3/4. And can I go back even further? Can you figure out what f is? Well, let's add 1 to this. That's 4/4 plus 3/4 will be t to the 7/4. And yet, if I take the derivative of this, wouldn't that come down here? But it's not there. So there must be something present in the original antiderivative. Going backwards, we say antiderivative. There must be something present in the original antiderivative that makes this 7/4 go away when it comes down, because it's not here for f prime. So how about 4/7? That way, when I bring down 7/4, these cancel. So I can go backwards by adding 1 and seeing if that's the same thing as pushing that up, which it was here, or I can add 1 and then check to see what if I move that down. Well, it's not there. I'd better have something in the original function so that when I take its derivative, I end up here with f prime. Okay? We're going to be doing a lot of going forwards and backwards next semester. Today, not so much. Just a little taste. Okay. Now, some straight derivatives. How about y equals 3x plus 4 squared over 2x minus 1 to the third? Please find dy dx. Go ahead, pause the video. I'll go. Hey, welcome back. I think I'm going to use the quotient rule. I know. The last video was all about I'm not using the quotient rule. Well, I feel like you have to practice the quotient rule because sometimes you can't not do the quotient rule. So what do we have going on here? We have low d high minus high d low. The derivative of this, bring down that 3. Leave the inside alone. Subtract 1 times the derivative of the inside. And all of that over low squared. Now, this is fine for free response, but for multiple choice, we want to tidy it up. In Chapter 5, when we have to set something like this equal to 0, we probably want to tidy it up. So I'm thinking about those problems we did last year in pre-cal, and again in the summer packet, and again in August, where we did some GCF factoring. So if I pull out a 2x minus 1 to the smaller power and a 3x plus 4 to the smaller power and a 6, what's left over? Well, I've got one of these. This is gone, this is gone, this is gone. My minus sign. I've got one of these. Don't forget the parentheses because you have to distribute that negative. And all of these are gone. Okay, and then we're over. Raising a power to a power, you multiply. 2x minus 1 to the 6th. Cool, so where does that take us? Well, 2x minus, no, it's 2x minus 3x is negative x. Minus 1 minus 4 is minus 5. Yes, you could take out that minus. And on the bottom, when I cancel, 2x minus 1 to the 4th, and I took out that negative from here. Great. So there's y prime. That wasn't so bad. How about product rule? Y equals 3x plus 4 squared 2x minus 1 to the 3rd. Please find dy dx. Welcome back. So product rule, this times the derivative of that. Derivative of this means I bring down that 3. I leave the inside alone. Don't forget to subtract 1 times 2. Plus this. Times the derivative of that. No, all over. That's it. Here we go. And again, it might be good practice to pull out that 3x plus 4 to the 1st and that 2x minus 1 to the 2nd. And that's a 3 and a 2 and a 3 and a 2. So I'm also going to take out 6. And what am I left with? One of those. And one of those after the plus sign. So I'm going to have 5x plus 3 times 2x minus 1 squared, 3x plus 4, and don't forget that 6. All right, just a couple more, and then we'll get to the worksheet. How about y equals secant of 3x squared? Find dy dx. No looking. You should know the derivative of secant. Okay. Derivative of secant is secant tangent. And don't forget to come and take the derivative of that inside function. Oh, I didn't mean secant after all. I meant secant inverse. Will you please find the derivative of secant inverse? Okay, so the derivative of secant inverse, 1 over. And now, notice how this is always absolute u. Well, this is always positive. So I don't actually have to put the absolute value bars. Yes, of course you can put the absolute value bars. But, yeah, I'm not going to, because that's always positive. So, what goes in here is this squared. 9x to the 4th minus 1. And of course, don't forget to take the derivative of that. Oh, I guess we could do some canceling this one. That one up, but if that was always positive, that could be negative. And so now I really do want that absolute value back. So this is going to take one of those, a 3 from here, and a 3 from here. So I think I'm going to go with that with a 2 on top. Great. Okay. How about this one? Y equals log base 2 of sine of 3x. Please find y prime. Okay, so remember, the derivative of log base b of stuff is 1 over ln of b times stuff times the derivative of that next inner function times the derivative of that innermost function. And that's not a b, that's a true. So we've got cosine over sine. So how about 3 over ln of 2 cotangent 3x. All right. Yeah, don't forget your derivatives of logs and exponentials, please. I want to practice logarithmic differentiation. And don't forget our dear friend, implicit differentiation. So here's our curve, and we'd like to write the equation of the normal at through the point 1, 2. Hold that thought for a second. That's going to be 6. That point is not on. There's no way I'm doing that. No. If that's a 2, that's a 1. That can't be. We're going to go with 1, 2. I'll go with 1, 2, but I'm changing this number to be 6. All right. So let's do some derivatives because we need a slope to write the equation of the normal. If I do a derivative here, I'm going to have 2xy plus x squared dy dx. Remember, this is a product, so I'm using the product rule. Now a plus sign, and then, another product. And the derivative of a constant is 0. So I'm going to keep the dy dx stuff over here and move things over there. X squared plus 2xy dy dx equals negative y squared minus 2xy. And then I divide. So now that I have the derivative, I can evaluate that derivative at 1, 2 to see what my slope would be. Well, if I plug in a 2 here, I'm going to have minus 4, and on the bottom, 1 plus 4 is 5. So negative 8/5 is the slope of the curve at that point, but I need the normal. So the slope of our normal will be opposite, change that sign, reciprocal, 5/8. Okay, so let's write that equation. We know the equation of the normal would be y minus 2 equals 5/8 x minus 1. Done. All right, let's now finally take a look at that worksheet. I, of course, recommend that you do the worksheet yourself before you watch this part of the video. Also, please note that in the left column on this worksheet are all the problems, and the right column on the worksheet are all the answers. Every year, someone doesn't pay attention to that, and every year I have people trying to take the derivatives of the second column, and some of those are really quite horrible. So please don't. just take the derivative of the first column, the numbered problems. Okay, number 1. Y equals 7x to the 4th minus 3x to the 3rd minus x. So y prime is going to be 28x to the 3rd minus 9x squared minus 1. Okay, that's what the answer is in the answer column. Nice. 2, y equals 1/2 to the x. You know, you really want to screw with people, you just turn that into, and then it's 2 to the negative x. And so the derivatives for either of these should be the same. We know that the derivative of an exponential is itself times ln of the base. AP multiple choice isn't going to write this. They're going to have instead 2 to the negative 1, because then they're going to pull that down in front. And they're going to have negative ln of 2. And they might even, 2 to the negative x. Do something like that. But this is fine for our free response, but maybe our multiple choice will look like that. Problem 3. So 3 says y equals x squared times x squared. Well, why wouldn't you just make that x to the 4th and then say that y prime is 4x to the 3rd? I mean, would you really want to use product rule here? Alright, well, this times the derivative of that plus that times the derivative of this. And so what do we see? We've got 2x to the 3rd plus another 2x to the 3rd. 2x to the 3rd plus 2x to the 3rd turns out to be 4x to the 3rd. I'll get to the same place. It'll just take longer to get there. Okay, number 4. Y equals 2 to the 3x. Well, we know that y prime is going to be itself times ln of the base times the derivative of the top. Okay? How about 5? Times 4, 5. 5 says y equals 2 raised to the x power. Okay, well, remember, the derivative of an exponential is the exponential times ln of the base times the derivative of that inside function. We know the derivative of e to the x is e to the x. Okay. 2, e to the x, yep, that's great. 6. 6 looks like a product rule. Y equals e to the x ln of x. And so y prime is going to be e to the x times 1 over x plus ln of x times the derivative of that, which is e to the x. Or if we tidy this up, 1 over x plus ln of x. Great. 7. 7 says, you're going to need more space. 7. Y equals x squared ln of x squared. So y prime, I see the product rule, 2x ln x squared times, no, derivative of that times that, plus that times the derivative of that. Well, the derivative of ln of stuff is 1 over stuff times the derivative of stuff. Okay, so what's going to happen? That's going to cancel. I'm going to pull out a 2x, and I'm going to have ln of x squared. Hey, remember, when we factor that out, we're dividing, so 2x divided by 2x is not 0, but in fact, after that plus sign, we have a 1. Okay. So y prime simplified, y prime not simplified. Problem 8. Do you have the sort of urge to multiply by the conjugate here? Rationalize the denominator? I kind of do. Maybe I'll come back and do that next. But for now, I'm going to think about using the quotient rule. Low d high minus I d low. The derivative of this is 0. The derivative of x to the 1/2 with a minus in front is minus 1/2 x to the minus 1/2. Don't forget all over 2 minus square root of x squared. Yeah, I see some things that I could tidy up, like minus 2 and minus 2. I could distribute that, but there's 3 terms here, and so I'm not going to be able to factor that thing out. Yeah, but what did I have before? Negative, oh, wow, I did tidy it. No, I didn't. It's 4 minus, I did tidy it. So, and then that becomes plus. So what is this? 4 minus 2 square root of x plus 1 over square root of x all over that denominator. Are you sure this is right, Mr. People? Yeah, I don't know. If I make a common denominator, and now I don't want to do that. I like it though. Huh. Oh. Alright, gotta go back and take a look, because, no one said anything about that one being wrong before, or would have changed it. Alright, well, now that I'm actually going to waste some time digging into this problem, I just want to see what happens. I don't think this is where the answer comes from. I just want to see. So I'm going to have 2x, 2 plus root x over 4 minus x. Well, that's a nice denominator. And I can distribute here. 4x plus 2x to the 3 halves. How did I get x to the 3 halves? This is x to the first times x to the 1/2. When I'm multiplying the bases of the same, I have the exponents. Over 4 minus x. Well, this is still y. I haven't taken a derivative yet. So let's see about taking the derivative. Y prime would be low d high 4 plus, bring that down, 3x to the 1/2 minus high d low. Derivative of negative x is negative 1 all over 4 minus x squared. And maybe I like that more. It seems less fraught, but it's not the answer on the worksheet, so I'm going to go back and do it that other way. Okay, and let's change this at the start to x to the 1. So y prime, low, d high, minus high, d low, over low squared. And that's the low squared that I see on the worksheet. So let's see what happens here. I'm going to distribute the 2. I have 4 minus 2 square root of x. Minus times minus is plus. Those cancel. X times this. Oh, I'm multiplying and the bases are the same. I add those exponents and I get plus x to the 1/2, which is square root of x. So what's going to happen here when I combine like terms? I'm going to have 4 minus root x on top and 2 minus root x squared on the bottom, and that's the answer on the worksheet. So, yep, go slow, take your time, remember your rules, practice your derivatives, life will be good. 9. Y equals tangent 1 over x. So y prime then? Well, derivative of tangent is secant squared. Leave the inside alone. Don't forget to come back and take the derivative of that inside function. Now, how did I get that? Well, remember, 1 over x is the same as x to the minus 1 power. So when I take the derivative of that, I bring down that negative 1. Right? Negative 1. X raised to, and don't forget to subtract 1, minus 2. So negative 1 times x to the minus 2, or if I move that to the bottom, negative 1 over x squared. Okay, there's problem 9. How about problem 10? Oh, so, you know, you could do this the long way, where you say, oh, I better use the power rule, leave the inside alone, times the derivative of that inside sine function, and then over here, bring that 2 down, leave the cosine alone, times the derivative of cosine, which is minus sine. And so I end up here then with 2 sine x cosine x minus 2 sine x cosine x. And so these are opposites, they cancel each other out. But really, wouldn't it be a lot easier just to say, oh, that's that Pythagorean identity. That's equal to 1. And so dy dx, the derivative of a constant, is 0. I think that's the way I would like you to do that problem. But I'm glad you could do it the other way as well. The other way just offers more opportunities for mistakes and chews up more of your time. Okay, what's next? 11. 2x squared plus x y plus y squared equals 10. Okay, don't use product rule here. Just print out the 2. 4x product rule here, though. Because the derivative of y with respect to x, that's the derivative of y with respect to x. And then here, the plus sign, we bring down that 2, we leave the y alone, we subtract 1, times the derivative of the inside y with respect to x. Derivative of 10 is 0. So I'm going to move the, I feel like I've missed something. No. Okay, I'm going to move the not dy dx stuff over there. X plus 2y dy dx equals negative 4x, minus y. And so if I divide both sides by x plus 2y, I get that, which is in fact exactly what I had on the answer sheet. Okay, 12. Y equals sine inverse 2x. So, that's a very interesting restraint there. Interesting. Yeah, you won't have to worry about any of those restraints on the AP exam. Now, if this were honors AP Calc, yeah, we'd be busting your chops all over about restrictions like that. So, y prime, 1 over square root 1 minus u squared times the derivative of u. Yep. And 13. Ooh, y equals x to the x. It's logarithmic. Let's give ourselves some space for this. Okay, 13. Y equals x to the x. So I take the ln of both sides, and I get ln of y equals x, ln of x. That's product rule. Here, 1 over stuff times the derivative of stuff. Here, product rule. So dy dx equals y times ln of x. This x and that x cancel, leaving me just plus 1. And we're not quite done yet. Remember, you have to replace y with x to the x. So x to the x, ln of x plus 1. There you go. So, I hope that prompts you. I hope you figure out where you might be needing a little more practice, and I hope you'll give yourself that present of practicing a little more. See you at the test.